Hello, everybody. It is time for Mr. Troy Explains Your Math Homework, a video series that has never had theme music. I apologize for the backwards baseball hat. Didn't think I was going to record a video, but hey, here we are. I'm going to go through a couple of your homework problems. Feel free to zip through this, fast forward to whatever you need. Just wanted to give you a chance to, have them talked through. Okay, the only problem is that your numbers may be slightly different than mine. For that, I apologize, but there's nothing I can do about that. I can't do everyone's homework for them. Okay, I have some problems that are asking me to multiply. We are going to treat the coefficients and the variables differently. So I'm just being asked to multiply 4 times negative 2 and z to the 6th times z cubed. I don't need a property of exponents for the 4 times the negative 2. That's just negative 8. I do need a property of exponents for the z to the 6th and the z cubed. I add those powers together. I'm going to get z to the 9th. By the same token, on the next problem, I'm going to get negative 20 x to the 6th. All right. Problem 8, part A, is meant to remind you that when you raise an entire expression to a power, you're multiplying that entire expression by itself. So for that reason, this is going to be 16x squared. Part B is to remind you that when you raise anything to the 0 power, except 0, but that's later, you get 1. So 4x to the 4th, all raised to the 0 power, is just 1. All right, let's take a look at some others. All right, 14 and 15 are popular ones for questions. 14a, we need just to think, is there a perfect cube that divides into 54? And it can take a second with your multiplication tables, but I believe, if I'm not mistaken, that this is the cube root of 27 times the cube root of 2. Now the cube root of 27 is 3. This is be 3 cube roots of 2. I'm going to trust from geometry that for the square root of 50, you can get that down to 5 root 2. So we're going to look at the square root of x cubed and the square root of y to the 4th. Okay, so x cubed is x times x times x. These two that are a pair, I can take the square root of, and that's going to be x times the square root of x left over. Y to the 4th is y squared times y squared. Those are a pair, so when I take the square root of y to the 4th, I get y squared, with no remainder, no leftover. So the question is, do I need absolute value bars? And if so, why? If not, why not? Kind of the key phrase to remember is ask yourself, am I going from even to odd? So, example, here, I'm going from y to the 4th, which is even, to y squared, which is still even. So this shouldn't require absolute value bars. The reason is that if I plug in negative 1, it's going to evaluate to the same thing, positive 1, as if I plug in negative 1 for the result, positive 1. So don't need absolute value bars for the y. I can leave the y squared like that. Do I need it for the x? Well, if I plug in negative 1 here, I'm going to get I. The square root of negative 1 is I. And if I plug it in here, I'm also going to get an imaginary. Okay, so when it evaluates to imaginary like that, I do not need the absolute value bars. there's an interesting question to be asked about, okay, so what happens if I am taking, say, the square root of a negative? But that's a different question for a different time. So I would say now is a good time, if you haven't done 15a already, to stop and see if you can apply that knowledge. Okay, so pause the video. If you haven't done 15a, see if you can use that to answer 15a. Okay, so hopefully you paused. How would I know? 10 does not have a square root, at least not a nice one, but the square root of x squared is the absolute value of x, kind of by the definition we talked about earlier today. Now 90 does have a simplified form, the square root of 90, because that is 9 times 10. So this is going to be 3 times the absolute value of x, root 10. So 6 of something minus 3 of that same thing is going to give me 3 times the absolute value of x, root 10. Normally we write the roots last. We kind of talked about that in class. It actually doesn't matter because multiplication is commutative. Okay, for this last one, I can take the cube root of 27 and I get 3. So when I pull that 3 out, it's going to multiply into that 6 and become 18 times the cube root of x. Now, good news is we don't have to worry about the variable because it's a smaller exponent. It is not divisible. 1 is not divisible by 3. Moving on to the next part, I can take the cube root of 64. I get 4, which I then multiply by this 1/2, and I get 2 cube roots of x. Subtract that, and I get 16 cube roots of x. And okay, our final one is number 20. It's asking us to write this in radical form. So I am raising 4 to the 1/2 power. So that's the square root of 4. This negative sign, which indicates that I'm multiplying by -1, is not inside the power. So the negative would go out here. So simply translating this into radical form would be the opposite of the square root of 4. All right, I hope that was helpful. Stay tuned for more great videos that do have theme songs. Catch you later.